Today, we're diving into what a lot of people are calling the next big wave in AI. It's an approach that's all about combining two completely different kinds of AI minds to build something way more powerful and, honestly, way more reliable. Let's get right into it.
This quote from AI researcher Gary Marcus really hits the nail on the head. He's saying that for all the amazing things modern AI can do, to make it truly trustworthy, we need something he calls symbol manipulation. Basically, we need an AI that can reason with concepts and logic, not just crunch a mountain of data.
And yeah, that's the big question, right? It sounds super academic, but it's actually the key to fixing one of the biggest, most talked about headaches with the AI we use every day.
You've probably seen this yourself. You ask a chatbot a question, and it gives you an answer that sounds incredibly confident, but is just completely, utterly wrong. That's a hallucination. It's a huge clue that the AI doesn't really get it. It's just a world-class pattern matcher. And the fix that researchers are getting excited about is this really cool hybrid approach.
And that brings us to Neuro-Symbolic AI. The big idea is actually pretty simple. Instead of betting everything on one type of AI, you combine two totally different schools of thought. You take the pattern-spotting genius of today's neural networks, and you merge it with the cold, hard logic of symbolic reasoning.
And here's the really cool part. This isn't just some random engineering trick. It's an idea that's directly inspired by the two different ways that you and I think every single day.
You might have heard of the Nobel Prize-winning book, Thinking Fast and Slow. In it, Daniel Kahneman breaks down our two modes of thinking. You've got your fast, intuitive, gut reaction system, and then you have your slow, deliberate, step-by-step logical system. Well, it turns out that this is a perfect blueprint for building a smarter AI.
So let's break these two systems down, because they map almost perfectly onto the two major branches of artificial intelligence.
All right, first up, you've got System 1, the fast thinker. This is your intuition, that gut feeling. In the AI world, this is absolutely the territory of deep learning and neural networks. You know, the tech behind things like ChatGPT or Midjourney. This neural AI is lightning fast. It's incredible at spotting patterns, like finding a face in a crowd or figuring out the next word in the sentence. But because it's so intuitive, it doesn't really know why it knows something. And that's where you get those weird, nonsensical mistakes, those hallucinations we were talking about.
Okay, now let's meet the other side of the brain. System 2, the slow thinker. This is the part you fire up to solve a puzzle or follow a recipe. In the world of AI, this is good old-fashioned symbolic AI.
Now, this approach is the total opposite of a neural network. It's not about intuition at all. It's about pure, unadulterated logic. It works with clearly defined rules and symbols, which makes it amazing for things like planning, logistics, and deduction. It's like a computer program just following a very precise set of instructions, one step at a time.
So let's just put it side by side. You've got neural AI, fast, intuitive, amazing with patterns, but can get things wrong. Then you've got symbolic AI, logical, precise, but can be really rigid and inflexible when faced with the messy real world. For decades, these two approaches were basically rivals. But that's all starting to change.
So what's the big solution here? Well, instead of forcing a choice between one or the other, the goal now is to create a single, whole-brained AI system. By smashing them together, the hope is to finally get the best of both worlds. You get the pattern-matching genius of a neural network, but it's guided and checked by the common-sense reasoning of symbolic logic, the gut and the brain working together. You can really see the goal here. Neural AI is off the charts in pattern recognition, but low on reasoning. Symbolic AI is the exact opposite. But look at that third bar, the neuro-symbolic approach. The whole point is to be strong in both categories, to fill in those weaknesses and create a much more complete and capable intelligence. Now, to be clear, this idea isn't brand new. Researchers have been kicking this around since the 90s, but it's really hitting its moment right now, mainly because the hallucination problem with large language models is so obvious. Big companies like Amazon are already using these kinds of systems to make their warehouse robots smarter and their shopping assistants more accurate.
Okay, so this all sounds great in theory, right? But how do you actually get these two totally different systems to talk to each other and work as a team?
There are a bunch of different ways to wire them together, but let's zoom in on one of the most famous examples in AI history, because it makes it all crystal clear.
One popular method is something researchers call symbolic bracket neural. You can think of it like a boss and a super talented consultant.
The symbolic system is the boss. It's in charge making the high-level logical plans. But whenever it hits a problem that needs a gut feeling or some creative pattern spotting, it calls in its neural network consultant to handle that specific task.
And the absolute classic example of this is DeepMind's AlphaGo, the AI that beat the world's greatest Go player. Its slow thinker, the boss, was a classic symbolic search algorithm that logically mapped out tons of possible moves. The problem is, there are more possible moves in the game of Go than there are atoms in the known universe, so you can't check them all. And that's when it called on its fast thinker, a deep learning network, to give it an intuitive hunch about which moves felt the most promising. It was that combination of logic and intuition that made it completely unstoppable.
So where is all of this headed? I mean, what's the end game for getting these two AI minds to work together?
Well, this is way bigger than just fixing chatbot errors. For researchers like Gary Marcus, this hybrid approach is a critical stepping stone on the very long road toward artificial general intelligence, or AGI, an AI with the kind of flexible, human-like intelligence we see in science fiction.
He even lays out a kind of roadmap with 4 key ingredients needed for truly robust AI. First, what we've been talking about, hybrid architectures. Then you need large-scale knowledge bases, basically giving the AI a curated library of facts about the world. Third, it needs powerful reasoning mechanisms to actually think about all that knowledge. And finally, it needs rich cognitive models, a real understanding of basic concepts like time, space, and cause and effect. A solid neurosymbolic system is really the foundation for all of it.
But, and this is a big but, this is far from a solved problem. It all comes down to one of the biggest, hardest questions in the entire field. How do you get a machine to learn and reason with basic common sense? You know, the stuff that's just obvious to a 5-year-old, that you can't pull on a rope to push something, or that water makes things wet? Cracking that is the next great frontier on the path to a truly intelligent machine.